Now, let's study all these waves in details. Let's start first with gamma rays. The question is, what are gamma rays? Gamma ray is a packet of electromagnetic energy or photon emitted by the nucleus of some radionuclides following radioactive decay. You have already studied about radioactivity, so you know that gamma rays originate from the nucleus. Gamma photons are the most energetic photons in the electromagnetic spectrum. As gamma rays have high frequency, or you can say that they are high frequency electromagnetic radiation, they carry a lot of energy. They can pass through most types of materials. Only an observer, such as a lead block or a thick concrete block, can stop their transmission. What is their source? In many alpha and beta transitions, that means in the process of radioactivity, the residual nucleus is formed in an excited state. The nucleus can lose its excitation energy and move to a fundamental level in several ways. The most common transition is the emission of electromagnetic radiation called gamma radiation. So that means gamma radiations are obtained when the nucleus is in the excited state. To release its energy, it emits gamma radiations. So remember, gamma radiations have nuclear origin and have a lot of energy. The high energy of gamma rays enables them to pass through many kinds of materials, including human tissue. Very dense materials, such as lead, are commonly used as shielding to slow or stop gamma rays. Now here you can see a differentiation where you can see what is the penetration power or difference in the penetration of alpha, beta and gamma. So alpha can be stopped by paper, beta can pass through paper but stopped by plastic, whereas you have gamma rays which are able to pass through the steel and lead also. Some radiations can pass through lead, but mainly lead is the absorber of gamma radiations. Now, uses of gamma rays. We already have studied that gamma rays have high energy. So accordingly, and can penetrate the human body. So accordingly, they have been put into certain uses. They can sterilize medical equipment, sterilize the food, irradiate food, used as tracers in medicines, in radiotherapy, in oncology to kill cancerous cell. Gamma rays, can kill living cells because they can penetrate inside, a fact which medicine uses to its advantage, using gamma rays to kill cancerous cells. They are also used in astronomy. Now, let's study about the next waves, which are X-rays. So, what are X-rays? X-rays are the electromagnetic waves which are emitted by the atoms of those metals which have high melting point when highly energetic cathode rays are stopped by it. They have wavelength in the range of 0.1 angstrom to 100 angstrom. Who discovered X-rays? A scientist named Röntgen discovered X-rays. He discovered Invisible electromagnetic waves of short wavelength ranges from 10 to the power of minus 13 meter to 10 to the power of minus 8 meter, and found they have high energy. He called them unknown rays. That is why they are called X-rays, because he didn't know what they are. What are important methods for production of X-rays? Well, they are produced in an apparatus known as Coolidge tube. Now, let's see what are the properties of X-rays. They are not deflected by electric and magnetic fields. This property distinguishes them from the cathode rays and also shows that they do not consist of charged particles. They are propagated in straight lines with velocity of light. They affect a photographic plate even more strongly than light. They ionize the gases and also eject electrons from certain metals on which they fall. They cause fluorescence in many substances. Example, barium platinosinide, cadmium tungstate, zinc sulfide, etc. They are highly penetrating and can pass through many substances which are opaque to ordinary light. They can penetrate through human flesh but are stopped by the bones. This is a very interesting and important properties of X-rays, that they can penetrate through human flesh but are stopped by the bones. X-rays, being electromagnetic waves, can be reflected, refracted, diffracted, and polarized under suitable conditions. They have a destructive effect on living tissues. Now let's see what are the uses of X-rays. See, X-rays penetrate certain materials better than others. This allows X-ray photographs which show the interiors of objects. Example, hard X-rays penetrate healthy tissue but not bone or damaged tissue, so they are used in medicine. Certain cancers are more vulnerable to X-rays than healthy tissue, so X-rays are used in treatment. In industry, X-rays are used to image machine interiors without taking them apart, showing up cracks and flaws. So here you can see an X-rays to be used to see the interior of the hands. You know, your all fractures are detected by means of X-rays only, because they are able, they are able to pass through the tissues but not the bone. Now, what is the difference between gamma rays and X-rays? The key difference between gamma rays and X-rays is how they are produced. Gamma rays originate from the settling process of an excited nucleus of a radionuclide after it undergoes radioactive decay. Whereas X-rays are produced when electrons strike a target or when electrons rearrange within an atom. Let's come to ultraviolet radiations. Ultraviolet is one of the electromagnetic radiation which is emitted by the sun and is transmitted either in the form of waves or particles with varying wavelengths and frequency. Detection. This is very important. How are the ultraviolet detected? When silver chloride solution is exposed to electromagnetic waves starting from the red to the violet end and then beyond it. That means silver chloride solution is taken from red towards violet and beyond violet. It is observed that from red to the violet end, the solution remains almost unaffected. That means when the silver chloride solution is moved from the red to the violet end, the solution remains almost unaffected. But just beyond the violet end, the solution turns violet and then finally it becomes dark brown. That means when we were moving the silver chloride solution from red to the violet end, there was no change in it. But as soon as it moved beyond the violet end, the solution turned violet and then finally it becomes dark brown. That means there is some kind of activity which is taking place beyond the violet end. So, this shows that there exists certain radiations beyond the violet extreme of the visible part which are chemically more active than the visible light. So, these radiations were given the name ultraviolet radiations or actinic rays since they are chemically active. Remember, ultraviolet radiations are obtained through a quartz prism as glass absorbs these radiations. So, an ordinary glass prism will absorb these radiations and only a quartz prism will be able to pass the ultraviolet radiations. Use of ultraviolet rays. Ultraviolet rays can be used to kill microbes. Hospitals use UV lamps to sterilize surgical equipment and the air in operating theaters. Food and drug companies also use ultraviolet lamps to sterilize their products. Suitable doses of ultraviolet rays cause the body to produce vitamin D, and this is used by doctors to treat vitamin D deficiency and some skin disorders. Next, in order of the electromagnetic spectrum is visible light. The electromagnetic radiation of wavelength from 4000 angstrom to 8000 angstrom are called visible radiations or visible light. Because in the presence of these radiations, other objects are seen by us. The visible part of spectrum was discovered by Newton. The prominent colors of visible light are given by Vibgyor. What is the source? The sun, electric bulb, white hot bodies. The uses in photography, photosynthesis, and to see objects around us.